All right, we're going to be talking about bearing problems for the next 2 or 3 days. There are actually two different ways that you can label, I guess you would say, bearing. So we're going to look at the first way today and then the second way tomorrow. Okay, so the first thing we need to talk about is that what we've been used to as far as measuring angles is that you start at 0 degrees here, and then you travel counterclockwise around the circle. So 90 degrees, 180 degrees, 270, and then takes you back to 360. Okay, when you are dealing with bearing, that is not how bearing is calculated. So when you're dealing with bearing, you're thinking more north, south, east, west, and you go north, and north is 0 degrees, and you go clockwise instead of counterclockwise. So if you're headed due east, that is a bearing of 90 degrees. If you're headed due south, that's a bearing of 180 degrees. And then due west would be 270 degrees. So that is how we're going to calculate bearing today. Okay, so this first picture right here, your ship has a bearing of 110 degrees. So you started at north 0, you're going clockwise. So you're going a little bit south of due east, because due east would be 90 degrees, a bearing of 90 degrees. So if you're going on a bearing of 110 degrees, you're going a little bit more southeast. Okay, the second one, we're the plane. So they are on a bearing of 270 degrees. Again, north is 0 degrees, you go clockwise, and then due west is 270 degrees. Okay, I want to add a couple little things. I think that next picture is a little bit confusing to start us off with. So let's do this first. We're gonna draw a bearing of B from A is 65 degrees. Okay, so what that says is you are going to start at A. Notice it says a bearing of B from A. So your starting place is A. So A is the origin, and you're heading towards B. Okay, well, A, if north is 0 degrees, okay, you're going clockwise. Here's 90 degrees, a bearing of 90 degrees, and then 180, 270. Okay, so if it's a bearing of 65 degrees, you start facing north and you turn clockwise 65 degrees. And then there you are now headed towards B. Okay, same concept. Bearing of B from A is 200 degrees. Okay, so same kind of thing. Move down here. So from A, you are starting at A. Okay, so here's A. Again, north is 0 degrees. East is 90 degrees. South is 180 degrees. And 270. Okay. So from A, we're starting at A, and then we need a bearing of 200. So again, starting north, and 200 degrees would be a little bit past 180. And so then if you head that direction, now you are going towards B. Okay. Okay, back to this picture here. Bearing of B from A is 60 degrees. So for this first statement, bearing of B from A. So A is your starting point. So from due north, you turn 60 degrees and you are now headed towards point B. Okay. All right, let me erase that. And then let's look at the other direction. So this time, a bearing of A from B. Well, if I start at B and I want to go this direction and head towards A, then I need to start north and then turn clockwise that far to get to A. So when you do that, this is 240 degrees. Okay, so how do you know that that's 240 degrees? So let's go back here for a second. Okay, so if this angle is 60 degrees, these north lines, these are parallel lines. Remember from geometry, parallel lines. So if this angle here is 60 degrees, this angle must also be 60 degrees because of alternate interior angles. So if that's 60, then I can take this whole angle measure then is 180, okay, 180 down to here, and then you add on that 60, and that gives you 240 degrees. Okay, so this is bearing of A from B. So I'm starting at B. You're going to turn 240 degrees, and then that takes you towards point A. Okay, so let's do a couple of examples here. The bearing from O'Hare to Danville is 168 degrees. What is the bearing from Danville to O'Hare? Okay, so from O'Hare to Danville, so here's O'Hare. We're going to start at O'Hare. 168 degrees. So here's north, 0 degrees. Okay, here's 90. Here's 180. So 168 degrees is going to be a little bit less than 180. Okay, so if I had that direction, then down here, here's Danville. Okay, so this is the representation. What is the bearing from Danville to O'Hare? So this time, we want to start at Danville. Oops. Okay, so this time we want to start at Danville. And I want to go to O'Hare. Okay, so Danville is now my point of origin. Okay, so it's going to be at the origin. So what I need to find is, this is due north, so that's 0 degrees. I need to find this angle measure. Okay, now I do know that it's more than 270 because this would be 90, this would be 180, this would be 270. So I know that angle measure is going to be a little bit more than 270. So here's a couple, there's different ways you can think about it, but here's one way. So if this is 168 degrees, to get to 180, you need another 12 degrees. Well, remember what we talked about, parallel lines. So you've got these north-south lines. Okay, so if this is 12 degrees, then this angle is also 12 degrees. Okay, so my bearing here plus 12 degrees makes one complete rotation, makes 360 degrees total. So this bearing is going to be 360 degrees minus 12 degrees, which gives you 348 degrees. Okay, now there's other angles here. You could have set this up kind of like a right triangle right through here, made a right triangle, and then you could have found this angle measure and then used it and done 270 plus that angle measure to get your bearing. So there's different ways that you can find that. So it's just going to take a little bit of practice. Okay, let's go on to number 7. A small plane leaves Danville flying 130 miles per hour with a bearing of 106 degrees. Okay, so let's see where this plane. So we're going to go, this is going to be Danville. Leaves Danville on a bearing of 106 degrees. So here's, okay, 0 degrees is north, 90 degrees, 180 degrees. So 106, go a little bit past 90. And there's 106 degrees. After flying 2.6 hours, how far is the plane from Danville? So that's going to be part A. Part B, how far east and how far south is the plane? And then C, what bearing should the pilot take to return to Danville? Okay. All right, so my plane is flying in this direction. My plane's down here. Okay, and it's flying at 130 miles per hour for 2.6 hours. All right, so if we multiply that, we get 338 miles. Okay, B, how far east and how far south is the plane? Okay, so if my plane is here, here's east, and then here's south. Okay, so this distance here is going to be my distance east. This distance here is my distance south. Okay, well, we already figured out from part A that you are 338 miles away from Danville. You know it has a bearing of 106. So this small angle right here would be an angle of 16 degrees because I got my 90 degrees right here, and then 16 would make the total of 106 degrees. So now you can use a trig function or two and find those distances. So I'm going to start with cosine of 16 degrees would be adjacent over hypotenuse. So that's going to be my distance east over my hypotenuse, 338. Okay, so if I multiply both sides by 338, I get east equals 338 times the cosine of 16. And that's going to give me 324.9 miles east. Okay, then I can do something similar to find the distance going south. So I can use sine of 16 degrees is that distance going south divided by 338. Multiply both sides by 338. And my distance going south is going to be 93.2 miles south. And I should label this what direction. So this one's east. Okay, part C, what bearing should the pilot take to return to Danville? Okay, so now we have switched places. So your point of origin now is where your plane is. Okay, so here's north. And then, so what we need to find is this angle measure here. Okay, well, again, this is 90, this is 180, this is 270. So I can find this angle is 16 degrees. So I can go 270 plus 16 degrees and that's a 286 degree bearing.